Hello friends, so today we will create a model, you can say the fruit segmentation using a UNet for pre-trained model. Okay, so let's get started. So this is the first library which we require to download dataset from the Riverflow. So this is a code to download dataset from the Riverflow. Let's get started it. Okay, it will take time, so don't wait for it. Okay, as you can see, the name of this, you can say the dataset will be labeled lab2 fruit1, but we have to rename it according to one, you can say according to our name. So the old name will be lab2 fruit1 and the new name will be fruit segmentation. So if the old name is exist and new name is not exist, we can rename it using this os.rename. It will rename it, as you can see when I will refresh it, fruit segmentation will come. Okay, now these are the libraries which we required for creating the data loader and also for the training purposes. So let's get started. You can say these are directories: image directory, image mask, and as you can see, we have a data.yml. We have a three classes: apple, banana, watermelon. But we do not perform the instance segmentation. We will perform the semantic segmentation here. So I will combine all these three classes into one, and the name of that particular class will be, you can say, uh, fruits. Okay, so what actually I want to say that we will not perform this instance segmentation. We will perform semantic segmentation. Okay, so for performing the semantic segmentation, I will combine all these three classes, as you can see, all these three classes into one class, and then the name of that particular class will be fruit. Okay, so when you will do this, we have a 2506 number of images and same number of images for the label, as you can see is okay. Now you can say this is the you can say we have to install the segmentation model PyTorch to load the pre-trained model UNet. Okay, to load the pre-trained model UNet, we have to install this segmentation model.pytorch. Okay, now how to load the pre-trained model according to our number of classes. So we have only two classes. The one is the b background, 0 is for the background, and the one for the fruit we use it. Okay, and how we have to load it. First of all, it's very important that we want to know that which on the training is performing on which device, whether it's performing on a CUDA or CUDA or a CPU. For that purpose, we use this line: if torch.coda is available. It means if it is available, then a device variable will get the value CUDA, otherwise will get the value CPU. Okay, so how we have to load the pre-trained model unit? It's very simple. It is, as you can see, we have import segmentation model.pytorch as smp. So in smp.unit we load the pre-trained model. Encoder name will be resonate34. You can say the backbone, we can see it encoder, and the encoder weight which we are using, weight we are using is a pre-trained weight will be using by the imaginate, and the in channel of the image will be 3, means RGB, as you can see it. And we have a classes 2. We have only two classes according. So this way we have load the pre-trained model according to our number of classes. Okay, and according to our number of images, and our model is ready. Then we have to load the model on a CPU or GPU we are using it. So let's get started it. It will take time to load the pre-trained model. It's completed. Okay, now we have to create the class. What is the use of creating the class? I will explain you that we have to create the class for to load the images, to load the labels, and to convert the YOLO polygon labels into the segmented mask. Okay, so let me explain you what it's mean. As you can see, let me open it. Let me open the label. Okay, then this one. As you can see that this first thing, this is, you can say, class ID, and these two things, you can say this other all things will is the coordinates values. Okay, coordinate values like this is the one pair, this is the one pair for xy pair for the first point, this is the second pair. So this way it's a polygon, we are giving it the points coordinates value to develop the segmented mask. And during training we required a segmented mask, not a polygon points. So for that purpose we have to create the class to which can convert the polygons points in YOLO to the segmented mask. So it's very easy. Just we have to create a class fruit segmentation dataset, then a dataset inheritance of the dataset. Then we have to initialize the you can say the variables. It's very simple. We will have to pass the image directory, labels directory, and transformation is better. What is the use of transformation is to resize the image, or we have to convert the image to two tensor, or we have to normalize the pixel values. These are the transformation which we apply to the images. If we do not apply it, its initial value will be none. Okay, otherwise we have to apply the transformation to both mask and the images both. So how we apply it, I will explain later. Okay, then after use this line, I want to know the image name of all image name. I have to make a list of all the images name in a sorted format. For that purpose, we have to use os.list directory, image directory. It will make all the list of all the image name present in a particular directory in a sorted way. We will get it, and everything will be stored in this image file name. Okay, everything will be stored in this image file name variable. Okay, now this is a length. Means when I will call this function, it will give me that how many number of images are present for the trading purpose. Okay, now this is a get item. Get item basically used to return the image and a mask, and here only we will convert all the polygons, means all the polygons polygon format into the mask. How we have to convert it? It's very simple. I will explain you line by line. So let's get started. First of all, using this IDX, we fetch the image name from the self.image file name variable which we have created here. Okay, with the list which we have created here. Okay, then after getting the image name, we have to make a complete image path. So how we have to make it is just very simple. It is os.path.join, then the self image directory and the image name. We will get a complete image name. Okay. After getting the complete image path, we will read that image, and if the image is exit, if it is not exit, we will means we show this message. Otherwise, it's important to convert the image from BGR to RGB, because you already know that CB2 read the image in the BGR format. So we have to convert that into the RGB format. So it's done by the CB2 CBT color. Okay, it converted. Now we have to make know the height and width of the image shape. Why? Because we have to create the mask. For creating the mask of the same shape of the image, we have to know the height and width of the image. For that purpose, first of all, we know the height and width of the image, and according to that, we will make the NP0. Means we have to make the mask. NP0 means all the pixel value will be 0 with the same size of height and width of the image. Okay. After that, we have to know the label path. So how we'll get a label path? It's very simple. It is, as you can see, you have to use os.path.join, then self.label directory. Okay, then the image name dot replace from, but just we have to replace the .jpg to .txt. We will get a complete image path. After getting the complete image path, if it is exit, if it is not exit, we will show message, or otherwise if it is exit, we will move inside the if statement. Then we open that label in the read mode as f, and everything will be stored in this f. Now we have to move, we have to iterate over the f one by one. So it's very simple. It is, so we will iterate over it, each line one object per one polygon. Okay, now this thing data.line.strip, because you already know, I already explained you that I already explained you that this first value, this first value, this 2 will be the, you can say the class ID, and other things is in a polygon coordinates values. Okay, so same way, when I will use this line dot strip dot split, this line will be like this with the class ID, and other thing will be coordinates value. When I will use this line dot strip dot split, everything will be give me this in a list format with the class ID and the coordinates values. Okay, now I want to get the class ID. For that, getting the class ID, we have to use this data dot zero int +1. And why we are adding +1 here? Because 0 index value is already fixed for the background. So because of that, every class ID means the zero class means, as you can see, we have 3 classes. According to dataset which we have downloaded it. Zero index value is fixed for the apple, but we do not need it. We have to change it, because 0 for the data for the model which we have trained, you are using pre-trained model, 0 is already fixed for the background. For that purpose, we will add +1 here for each, and then see how we have to get this points in a x y coordinates value or in a pair. It's very simple. First of all, np.array, we have to use np.array data starting from 1 till the end and reshape it to -1 and 2. As you can see, if data.I means like this, it give me skipping the class ID, make the list like this, and when I will use this reshape -1 comma 2, it give me the list like this in the pair format x and y coordinates value. After that, we will multiply all these values. As you can see, these are values are in normalized format. Okay, in a normalized format, but we have to unnormalize them. So according to that, convert normalized to pixel coordinates value. So to unnormalize them, we have to just multiply every value of x with the w and every value with of y with the height. So after multiplying it, if suppose the image size will be 100, after multiplying it, we will get this type of list. Okay, after getting a list, we will get a complete points values. After getting the complete points value, we will make a we have to convert those points value into the integer format. So this way we will convert all things into the integer format. After that, we will fill the mask which we have created here with the shape of height and width of the image, and every pixel value here is 0, but we have to convert the that particular portion or that particular object position coordinates value or segmented area with the class ID which we fetched. Okay, which we have fetched. So we have to change it according to class ID which we have. Okay, so for that purpose we have to use cbd.fillPoly. We'll pass the mask and the points according to the point, the area where the according to the points, the position pixel value inside the you can say the polygon, inside the polygon pixels value convert to the class ID which we are passing here. Okay, so this way we get a complete mask with the segmentation and okay, has with the segmentation. But till here we are not doing anything. Means if suppose the class ID will be, we have a 3 classes now, 0 1 2. So if the class ID will be 2, then the that particular position will get the pixel value 2. If the class ID will be 3, then the position that particular position pixels value will get a 3 you can say 3 pixel value. Okay, but we have to combine all those pixel value to 1. So how we will do it? Just very simple it is. We use np.where, and where in which where mask, in mask all those values which is greater than 0 will change to 1 and will change to 1 here. Okay, so this is the use of this. Here we combining all the 3 pixels value to 1, whether the pixel value will be 2, whether pixel value for the 3, whether pixel value 4, we'll combine all those pixel value to 1. It means we have only 2 classes, 0 and 1 for the fruit. So this way we combine all things and we get a complete mask here. We get a mask with only 0 and 1 values. And then if suppose we have to add some means we have to apply some transformation to the images, it's very simple it is. We have to use self.transform and pass the image and mask both, because we have to apply the transformation to both images and mask. And after that we have to retrieve the image and mask here, and we have to return the image and mask here. So this way we have created the class, and I hope I have explained you clearly what is happening here. Okay, now we have to create the data loader. Okay, so how we have to create a data loader? First of all, we have to make a transformation. So first of all, creating the transformation, we use compose. Then we have to make the list of all the transformation which we have to apply to the images. So for that, first of all, we have to resize it to 224 into 2 by 24, and we have to normalize the pixels value to mean and standard. And you already know we have a 3 value. We are passing the in standard also we are passing the 3 value, and the in mean also we are passing the 3 value. Why we are passing the 3 value? Because image have 3 channel R and RGB. So that's why we passing the 3 values here. And also we convert all the pixel value to tensor. To tensor means it's make the pixels value to the inside the range to 0 and 1, and also it convert the dimension of image from HWC to CHW. So there's a use of that. Okay, now and also it convert all the pixel value in a tensor format. So now this is the image train image directory and train image mask directory. After that, we have to make the object of the class which we have created it. This train dataset will be the object. Here we're passing the train image directory, train image mask, and the transformation which we have to perform on the images and mask both. Then we have to create a train loader. For that creating train loader, we are using the data loader. Okay, we are using the data loader function. Here we have to pass a train object. Then the batch size 8 means when the data loader divide the images into batches, then each batch has 8 images. Shuffle true, yes, shuffle will be true, and drop last true. What is the meaning of drop last true? Because it means that if suppose the last batch does not have 8 images or less than 8 images, we will drop that particular batch. Okay. Then criteria the loss which we are using is for the calculation of the loss during the training, we are using a cross-entropy loss, and the optimizer which is used for the updation of the gradient and the weights. For that we are using the Adam optimizer here. Model parameter, the learning rate will be 0.01. Okay, so I hope I have explained you this thing clearly. So let's get started. Let me run this cell. Okay, so when you will use this length train data loader 313 basically the number of batches which we have, and each batch have 8 images. And when you pass this length train data set, it give me 2506. It means the number of images which we have for training. Now this is you can see the segmented function. You can say it can be the segmented image, but I will not explain this function because I already explained this function detailed way in my video. You can go to my channel and see this video, image segmentation visualization with overlay and blending in Python. You will get a complete idea that how this function is working. So let me just run this cell. In short way, it just give me the segmented image. Okay. Now we have to plot some images. Alpha 05 is, you can say, the transparency which we required. We have our class name. We have only 2 classes, background and our fruits. You can say this is the color for decided by already decided for the background and for the class which we have. For getting the images with the labels, we have to use the first, we have to create the iterator. Then the next, it give me the images and mask both. Basically images and masks store the detail for 8 images, as the batch size will be 8. Okay. Then for the plottation of 8 images, we have to use plot.subplots. 2 is known as the rows and 4 will be the column. Figure size will be 20 by 15. Figure basically represent the entire subplot, and X is just for the iteration over the subplots. Okay. So for the plottation of the 8 images, we have to use this. We have to use for loop for the 8 time. For each iteration, I will get the image and the mask both. And here you have seen that we are using this permute 1 to 0. What is the use of this permute 1 to 0? Because as is seen in the transformation, when I will use this to tensor B2, it changes the dimension of the image from CSW to from SWC to CSW. But for the plottation, we require the original dimension. For that purpose, we use permute 1 to 0, which give me the original dimension HWC of the image, and we have to move that particular image and the mask to the CPU. So that's why it's having a dot CPU. And you already know that everything images and mask is in a tensor format. When we use this data loader, everything will be converted to a tensor format, but for the plotation we require it into the numpy format. For that purpose, we use this dot numpy here. Then just after getting the image and mask, I will call my function and just pass the image and the mask and other things. It give me the blended image. Then we will show the blended image, and the axis will be 0. Tight layout and just plot show. Now let me show you the result. As you can see that you can say the images is highly contrast, or you can say bright color will be there because the pixels value are the normalized. That's why. Now we have to train the model. For training the model, first of all, we use a TQDM just for the for using the visualization bar. Okay, and best loss is just have an infinite value, because at each epoch loss will decrease. So that during to save the best model, we used initial best loss initial value will be infinite. Then save path will be best model.pth. And after giving the save path, you can say this is it. Then we have a epoch 50. But right now I just want to train for the 5 epoch, because I already had a model which is trained on 50 epoch. If the epoch 5 and the model will not perform well, I will upload the model which is trained on 50 epoch and show you the result of that. Okay. Now, as you can see, we have a cosine analytic scheduler, but we do not using here. Okay. Or I think so we are using it here, scheduler, for the you can say to reduce the learning rate. Okay, how it's working, let me explain you later. But first of all, epoch will 5, then we have to store the loss for each epoch. For that purpose, we use train loss list. It initially will be empty. Now let me explain to this how the scheduler is working. For scheduler, we use torch.optimizer.lr scheduler, reduce RO and plateau. Okay, we just have to pass the optimizer mode minimum. Minimum means it will check the loss, and factor 0.5 means the learning rate will multiply by the 0.5. Patience will be 3. For example, we have let me see. For the first epoch, validation loss is 0.50. For the epoch second, loss will be 0.45, means the improvement is there. And for the third epoch, validation loss is 0.46. But the minimum loss is 0.45, means no improvement. In fourth epoch, 0.47, but the minimum is 0.4, minimum loss is 0.45, no improvement will be there. And for the 5, 0.48, no improvement is there. So for the epoch 6, it will multiply, it will reduce the learning rate, means it will multiply the, if suppose the learning rate, initial learning rate will be 0.01, it will multiply the learning rate by 0.5, and new learning rate will become 0.005. So, and it's wait for the 3 epochs, means patience is 3, factor 0.5, minimum means it will check the loss, optimizer just for the updation, means optimizer is used for the updation of grade, that's why it's have to pass the optimizer here. So this way we reduce the learning rate if after every patience 3, if there will be no improvement in the validation loss. Okay, it's suppose the validation loss or the loss which we are calculating here means your training loss. It's not required that validation loss is always calculated. We can calculate a training loss also. Okay, it should be train loss because we are not validating the model here. Train loss. Now we have to move inside the for loop for the epoch. How much number of epochs should we have? We have 5 epoch here. Okay, model train. This is the mode of the model, means the model is in a training mode. It means updation of the gradient will be performed here, and epoch loss, initial epoch loss will be 0.00. Okay, now we have to apply the TQDM. So TQDM will be, in TQDM we have to pass the train loader and the masses which we want to display. Okay, and one attribute leave will be true, means what the meaning of leave true means this bar it will not be display if the leave value will be false, means after training it will get banished, but if leave is true, this bar will remain as it is. Okay, now we have to move here. See, we have to, after that we have to loop over the train p bar. It give me this images and mask. If suppose I'm talking about the first iteration, that images and mask contain the 8 images detail and a mask detail, then we have to move this images and mask to a device where the model is, whether we are using the CUDA or a GPU. According to that, it will move the images and masks to the CUDA and a GPU where the model is. Then optimize the zero grade. Optimizer zero grade is used to make the gradient value 0. Why? If suppose we do not use this line, then the gradient value of the previous batch, not epoch, previous batch will be accumulated to the current batch gradient value, and it will disturb the training. So that in that purpose, to avoid this disturbance, we use optimize zero grade, which means the gradient value before for the current batch training. Then we just pass the images. As you can see, the dimension of the images will be an 1 HW. What, not 1, it should be 3 here. Okay, because we have a 3 channel RGB that for that purpose, and will be the number of batch. It should be 8 here because we have sat already. You can say as you can see it where it is gone. See here, batch size is 8, so dimension will be 8, 3 H and W. Okay. So that's purpose. This is the image dimension. Then we'll get the output. After getting the output, we have to calculate the loss. For that purpose, we use the criterion. We just pass the output and the mask. We will get the loss. Calculate loss. After getting the loss dot backward is used to calculate the gradient's value. Here the calculation of the gradient is performed. Optimizer zero step basically update the gradient's value. Okay, after that epoch loss, after getting the loss, we will pass the epoch loss. We will add that loss into the epoch loss dot item. After completion of all the batches training, we will move to the for loop of the epoch. After moving to the for loop of the epoch, we have to calculate the average training loss. So for calculation of the average training loss, we use this formula: epoch loss divided by length of train loader. After doing it, we have to store the you can see the loss epoch loss in the train loss list. Okay, then we have to apply the scheduler. Okay, you already know we have to apply scheduler in a for loop of the epoch, not in the batch for loop. Okay, after that we have to display the masses, and important thing, we have to save the model whose average loss is minimum, or you can say the training loss will be minimum. For that purpose, we compare the average training loss to the best loss, and best loss we have to update the best loss value if it is there. Then we have to save the model. Save the model, we just have to use this one line: torch.save model.state and save path, which we have. Then we will see the, we can say, display the messages and everything. When the for loop of epoch will complete, we have to show this message: training completed, best model save at this. Okay, so let's get started just for the five epoch. Okay, now to display the training loss for the, there is a training loss for the 50 epoch. I will show you how we are doing it. First of all, we have to plot the for the plotation we have to make the range, but here we have to just use it. Plot the figure size will be 10/16. Plot dot plot, we have to pass for the x-axis train loss list means, and train loss will be the values for the train loss. Then label will be train loss. Marker 0 means it will mark each value with this bright blue color. It will mark each value. Color will be blue. Label X label, Y label, title, listen, grade, true. You already know what is the meaning of that. Okay, so let's get started. It will show me the result. But let me show you the result of the 50 epoch. You can say train loss. Has it going down, down, down? Completely, it's working very well. But now let me run it. It will show the graph of the 5 epoch. Okay. Now we have to test the model, and also we have to load the pre-trained model. So how we have to do this? It's very simple. First of all, you already know we have to find the device which we are using, the CPU or GPU. Then the model path which through which we have saved the model. You can say it has to be same like this. Here the save path will be this, same model path will be there. Okay. Same model path. Now we have to load the model. No, first of all, we have to make the architecture, or you can say load the pre-trained model with Ryzen 34 backbone. So this way, same way, we will load the model. After loading the model, we have to load the weights. As you can see, this encoder weight will be no pre-trained weight will be there when loading a trained model. Okay. So now we have to load the weights file. For that purpose, we use this line: model.load.stateDict torch.load model path, then the map location device. Okay, now move to the model to the device which we are using. Now here the model mode is evaluation, means no operation of the grading will be performed here. Okay, now image directory, we can say for the testing is a directory. Then OAD loss directory means it will give me the list of all the images present in that particular directory. Okay, now the alpha 0.5, you can see this is the transparency. We have only two classes: background and fruits, color assigned for the you can say class index. And this is a transformation which we have to apply on our images during testing also, because it is compulsory that all the, you can say, transformation which we had applied during training, it should be applied during testing also. Okay, I'm not talking about that flipation, rotation, brightness. These also are the transformation which we have to apply, but we have to apply if there is a number of images less. But important transformation we have to apply during testing and training both same times. For example, the resize, conversion to tensor, and the normalization. After that, this is the function which I will not explain you. You can go to my channel and see the video. Okay. For the plotation of the 16 images with the like this, means the original image with the anti-segmented image. To perform this, we have to make two column, and each column has 16 images. Okay. For the plotation of 16 images, we have to use for loop for 16 time with the original image and the segmented image. First of all, it will select the random image from the images list which we have created above. After that, to make get a complete image path, we have to use os.path.join image directory and the image name. We will get a complete image path. After getting a complete image path, we will open that image into the RGB format. Okay, we read that image, then we will convert that image into a NumPy array format. Okay, then we have to make the image, we have to apply the transformation and unsqueeze 0. Why we have to apply the unsqueeze 0? You already know that during the training time, we are passing the image in a batch format. So here at during testing time, at same dimension we have to apply, but unsqueeze 0 which add one dimension, 1, then 3, then the size will be 2 to 4 and 2 to 4. It will be the dimension of the one image we are passing it. Okay, then we have to pass the images, input image, and we are just passing the, you can say, only single image. So 0 will give me the detail of the particular image, or you can say predicted mask, or the output. And what is the use of this torch no grade means no operation of the grade will be performed here. And now we have to get the predicted mask from this output. So it's very simple. For that purpose, we use this line: torch.argument max output dimension 0.cpu.numpy. Give me the predicted mask. And after getting the predicted marks, so we just have to resize it according to an image which we have. So first of all, we get the height and width, and then we have to resize it according to the height and width of the images which we have. So for that purpose, we use cv2.resize predicted mass, then width and height. Interpolation will be cv2 inter nearest. Okay, we get the predicted mass. After getting the predicted mass, we just use the function create oval and blend. Create overlay and blend, where we just pass the image and the predicted mask. It will return the segmented image to me. Okay, then we will show just image and the blended image as it is in front of each other. Okay, original image with the segmented image. This is side title, axis off. Now this will plot the image. Now if suppose the training will get completed, see, our training get completed for the 5 epoch, and the training loss is going down and down. Okay, now let me show the result of the model which is trained on just 5 epoch. If it not work well, I will show the result of the model which is trained on 50 epoch. Okay. Oh, it's working very well. Okay. As you can see, it's perfectly segmented the imaging fruits. Okay. Now it's working very well. From my expectation, is working very well. Yes. So it's working very well. It's somewhere it's not working well, but which you can improve by increasing the epoch value. Okay, if you increase the epoch value, more training will be there, and your model become more robust. So if you gain something important knowledge from my explanation, so please like, share, and subscribe my channel. Okay, thanks to all.